In this example, we're going to use optimization to correct an eye model. Here we have an eye with axial myopia, meaning that the rays are coming to focus before the retina. So if I zoom in here, we can see that the best point of focus is before the retina, which is here. So we would like our retina to be there, but it isn't. So we need to correct so we can push these rays back onto the retina. But how do we figure out how much to correct? Well, we can use optimization to do that. So to use optimization with AHEM, we need to go to the settings file of what we have generated in our system. So each time we run an eye model, a settings file is generated. So we open up that settings file. It contains all the variables that are inside the model. So if we know what variable we want to optimize for, we can select it from this file. Now there's a certain procedure that we need to do to use the optimization. So we can go up into our templates file and select AHEM Optimize Top. And so what it did was it inserted some code at the top here, the system new reset, units millimeter, and then insert settings file here. So here's my settings file, and I go down to the bottom. I click on AHEM Optimize Bottom, and then it inserts the bottom. So I need to have my settings file in between the red lines of the top and bottom of these two templates. This allows me to use the optimization state of AHEM. Now I want to optimize. I go into the editor and I say optimize script. So now I want to find the design variables to optimize for. Well, if I want to push the rays that are not focusing on the retina to the retina, I need to put some sphere on those rays. So I'm going to use sphere for design variable. So I'm going to search for that variable, and sphere 1 for sphere I1. And all these variables are listed within AHEM's library. So I'm going to find sphere 1. There it is. So I'm going to select it, and I'm going to right click on there, and I'm say define design variable. So its original number is 0, and now the optimization is going to figure out what the best power to put on the correction lens will be. Now my design objectives, I need something to design to. So there are various metrics that AHEM generates automatically, and full width, half maximum, and a 50% encircled energy are two good design objective metrics. So I want compact point spread function, and those two metrics describe the compactness of a point spread function. So I'm going to search for those metrics, or for one of them at least. Let's see, I've got full width half max of I1. So I'm going to look for that. There it is. So I'm going to select that in a similar way. Right click on it. So there's my design objective. So this is a very simple setup. And then when I'm done, I just say start optimization, and the optimization process continues. So the ASAP optimization finished processing, and it gave me a number for the sphere. So right now we're looking at a graphic of the ray trace after I've put sphere on a corrected lens. So let's see how that looks when we run it. Alright, so I've got my eye set up basically the way it was before, where I had two diopters of ametropia on it, and I was getting that axial myopia where the rays were focusing before the retina. So then I needed to correct it. So now I have a choice to correct that. So I have selection 1 for spectacles, and I got the data for the spectacle correction from the optimization that I just performed. So everything else here is the same, except now I've got input for a spectacle lens sphere. So here I've got minus 1.65, and I got that from the optimization. So I plug it in here, and I just say OK, and it generates the ray trace and the corrected eye model. So we'll look at some of these views. There's our point spread function, nice and tight and compact. You look at the plot. So here's it's a negative lens, so it's minus 1.65 power to make that nice compact point spread function pushed onto the retina now. So we can look at it. Circled energy looks good. And there's a cross-section of our PSF. So in summary, we took an aberrated eye with axial myopia and ran ASAP's optimization process using sphere of a corrective lens as a design variable. And then we used a design objective, full width of half max, and we tried to drive that to 0 because we want this half max full width to be as minimal as possible. And we ran that through the optimization, and it gave me a number of minus 1.65 diopters to put onto my corrective lens.